So what if I told you that the future of renewable energy isn't some high-tech gizmo in a lab, but, well, a giant box of sand? Seriously, forget lithium, forget cobalt. We're talking about a battery made from one of the most common materials on the entire planet. Let's get into it.
Now, this might look like a regular old grain silo, but it's not. This is a 23-foot-tall steel tower in Finland, and it's packed with 100 tons of ordinary sand. Its job? To act as a massive battery, storing enough raw heat to keep an entire town warm through the coldest months.
Okay, so the big question is, how on earth does that work? How can something so simple, so kind of low-tech, solve one of the biggest challenges in renewable energy? The answer is surprisingly elegant, and it all boils down to some pretty cool physics.
But first, let's back up and look at the problem. Why do we even need a giant box of hot sand in the first place? Well, it all comes down to a major headache in our transition to clean energy.
Here's the deal with renewables. The sun doesn't always shine, and the wind doesn't always blow. We all know that. But what you might not know is that sometimes they produce way too much energy. And when that happens, we literally have to just turn them off. It's called curtailment, which is just a fancy way of saying we're throwing away perfectly good, clean energy. You've probably seen it. Wind turbines standing totally still on a super windy day. That's potential power just going to waste.
And here's where it all clicks together. Take a look at where our energy actually goes. Nearly half, 46%, of the energy we use in our buildings is just for heating and cooling. And right now, most of that heat still comes from burning fossil fuels. So, what if we could take all that wasted renewable energy and use it to heat our homes and businesses? That is exactly the problem a sand battery is built to solve.
So, how do we actually turn that wasted electricity into useful heat? The concept is called thermal energy storage, and it turns out sand is pretty much the perfect material for the job.
Instead of storing electricity in some complex chemical battery, thermal energy storage, or TES, does something much, much simpler. It just turns electricity straight into heat and then stores that heat. You can think of it like a giant, super-insulated thermos that can keep its contents piping hot, not for hours, but for months at a time.
Now, you could use water to store heat, right? It's great for that. But it has a pretty hard limit. It boils at 100 degrees Celsius. Sand, on the other hand, can get way, way hotter. We're talking up to 600 degrees Celsius. And that incredible temperature difference means you can pack about 3 times more energy into the same amount of space. It's kind of like the difference between a cup of hot coffee and a glowing red-hot piece of steel.
So why sand? I mean, it's everywhere. It's dirt cheap, it's non-toxic, and it's not going to catch on fire. But the real genius is in its physics. It has a low specific heat, which means it heats up really fast, perfect for capturing sudden bursts of extra wind power. But you combine that with its high density, and you realize it can store a massive amount of heat in a pretty small space. It's just a beautiful, low-tech solution to a very high-tech problem.
Okay, so this isn't just a theory on a whiteboard. Up in Finland, a company called Polar Night Energy has already built the first commercial sand battery, and it's already heating homes, offices, and even the local swimming pool for a town of about 10,000 people. Let's take a look at how it actually works.
This is it, the world's first commercial sand battery. It's a simple and frankly brilliant design. Just a super-insulated steel silo filled with 100 tons of ordinary sand and a network of pipes running through it.
Okay, here's the play-by-play. When there's extra, cheap, renewable energy on the grid, it's used to power a simple heater. That heater warms up air, which then gets pumped through that network of pipes, heating up all the sand around it. The silo is so well insulated, it can store that heat for months with very little loss. Then, when the town needs heat, they just reverse the process. They blow cool air in, it gets superheated by the sand, and that hot air is sent out to the town's heating system. Simple.
And the technology at the very heart of this system? It's basically a giant toaster. I'm not kidding. A resistive heater, just like the coils in your kitchen toaster, turns electricity directly into heat. There's no complex chemistry, no rare earth metals, just simple, reliable, off-the-shelf physics.
And what's the result of this giant toaster? You get 100 tons of sand heated to a blistering 600 degrees Celsius. That's over 1,100 degrees Fahrenheit. It's just a massive reservoir of clean heat ready to be used whenever it's needed, even months down the line.
So this sounds incredible, right? Is this the perfect solution we've all been waiting for? Well, not quite. Like any piece of tech, it has some serious pros, but it also has some important cons. Let's do a quick reality check.
All right, the pros are huge. It uses cheap, common materials. It's built to last for over 50 years with very little maintenance. And crucially, it's fantastic for seasonal storage. A chemical battery slowly loses its charge over weeks, but this silo can literally store the intense energy of the summer sun and release it as heat in the dead of winter. Now the cons. Well, for one, it's big. It also really needs something called a district heating network to be useful. That's a system of underground pipes that moves hot water around a city to heat buildings, which is common in some parts of Europe but not everywhere. And it has one other major limitation.
And that limitation is turning the stored heat back into electricity. Now, you can do it. You'd use the heat to create steam and spin a turbine, but it's just incredibly inefficient. And this isn't a design flaw, it's just a fundamental law of physics. Turning a diffuse, low-grade energy like heat back into a concentrated, high-grade energy like electricity always involves some big losses. And here's why that really matters.
This chart tells the whole story. If you look at a lithium-ion battery, it's about 95% efficient at turning electricity back into electricity. Super good. Now look at the sand battery. For turning electricity into heat and then back into heat for your home, it's almost perfect, 99% efficient. But if you try to turn that stored heat back into electricity for the grid, the efficiency plummets to around 25%. So the takeaway is crystal clear. This thing is a fantastic heat battery, but it's a pretty terrible electricity battery.
So where does that leave us? Well, it means we need to start thinking about energy storage in a new way. It's not about finding one single perfect solution, but about having a whole toolbox and picking the right tool for the right job.
And that's the thing. A sand battery is not a silver bullet. It's not going to replace lithium-ion batteries for our phones or our cars, but it's an absolutely brilliant tool for a very specific and very important job.
Its perfect home is in cities or industrial areas that already have those central heating systems. For them, instead of burning natural gas all winter, they can just plug in a giant sand battery, charge it up whenever renewable energy is cheap and plentiful, and get all the clean heat they need all year round.
So as we race to build a zero-carbon future, maybe the answer isn't some super complex high-tech invention. Maybe, just maybe, it's been right under our feet this whole time. A simple box of hot sand could be one of the keys to a cleaner, warmer world. It kind of makes you wonder, what other simple solutions are we overlooking?